Hello everyone, and welcome to Module 1 of Class Number 2. If you haven't already, I highly recommend going back and watching the 4 modules that we've outlined already in Class 1. Everything is going to build upon itself, and again, if you're brand new to programming, this is really the foundational stuff that you'll need to learn. So today we're going to focus on if-else statements, match case, which is other programming languages you might have heard called switch case, and we'll look at that in some more detail. And then we'll also talk about how we run code over and over again in what we call looping, or loops. So buckle up. This is going to be a lot of hands-on today, and I'm going to have some challenges where I'm going to have you try to write some code yourself. Again, if you haven't already, I highly recommend installing and running Jupyter Lab, and that way you can follow along with me with this notebook. And I'm going to talk about if-else statements first. Then we'll move into talking about switch case, which is actually in Python 3.10 is when it first came out. That's called match case, and we'll look at that. And then we'll end today's class on looping, or this module's class on looping. So you've got a lot to cover. It is going to be a lot of hands-on, so make sure that you're ready for it. Buckle up and let's go. So the first thing we're going to talk about is code starts at the top, and it's going to go instruction by instruction down our list, right? So we're going to start at the top, runs the first statement, then it runs the next statement. If it comes upon what we call a conditional statement, it can change the flow of our code. So if I hit a condition statement, I may not run the next set. I might actually go somewhere else in my code. So let's look at the first conditional statement is the if-else statements. And this is going to build upon the operators we've already seen in the previous module, right, the previous class. So the double equals is a comparison. Remember, it's not an assignment. When you use two equal signs, we're doing a comparison. This is equals to, this is not equals, greater than, less than, we're familiar with those, and greater than or equal to, we're also familiar with those mathematical concepts. So we'll look at using those in our if statements. So let's add an if statement here. It's using the keyword if, and you'll notice right away that it turns that green bold highlighting. That means it's a keyword. Then I'm going to put my condition here. Condition goes here, and then after the condition, I put a colon. That signifies the end of my condition, or I should say conditions, because you can have multiple, right? It could be one or more condition statements. And we've seen how we string them together is by using and, or statements, and not statements. So these are how we're going to link things together. So what exactly is a statement? A condition statement? Something like, I don't know, we'll say age is greater than 21. I always like that as an example to show for drinking, and we'll define age out here to be, I don't know, 45. If this statement is true, it's going to run the code right below our if statement in its own code block. So if we go back and watch the previous modules, remember what code blocks are? These are code that's all indented to the same level and all line up perfectly. So here, I'm only going to have one statement. It's going to be print. And I'm going to print some statement of, I don't know, something along that line, right? So I've done this conditional statement where I get a Boolean result, right? Age is greater than 21. That's going to return a true or a false, so it's going to return a Boolean. So we have the if statement's going to do one thing if we have a true statement. So we'll go ahead and run that. And it says, hey, I'm old enough to drink. But what if I am 12? I'll run that, and it actually does absolutely nothing. It doesn't print anything out. Because what happens is it hits this statement, and the flow of control says, let's not do the next statement because this resulted in a false. Let's go back to the next non-indented section of code, which there isn't anything, so it ended the program. If I had done another statement here, something that says like end, now it'll print the end statement, and it skips printing this statement because they're not old enough to drink. Let's make them old enough to drink just so we can see it flowing and through and printing both print statements. There we go. So now we've got it working the way we intended it to work, using an if statement. I can do greater than or equal to, and say, hey, this person is exactly 21. What if I didn't have that equal sign? And I run this code. Hey, they're not old enough to drink because it's not equals to. So we got to make sure when we're doing our code that we use the correct comparative operator here. What if I want to say, is this person exactly 21? What would I put in the statement here? Would I do this, or is there another comparison operator I should put in there? Hopefully you remember that one equal sign is considered an assignment operator, not a comparison operator. We actually need to have two equal signs, as the example up here shows, and this is checking for equality. So we'll go ahead and run this code, and now you'll see that this statement returns back a true statement and actually prints our statement. If I wanted to have 2 in my code block, I got to do my, oops, well that's what's going on here. Let's put this back here, 1, 2, 3, 4. And let's do another print statement. Let's print the data type. And let's put in this data type here, just so you can see what data type it's creating. And you'll see that it's creating a Boolean data type. So this comparison operator gives us back a true or a false. Okay, so that's the if statement. And that's fine and dandy. It gives us a little bit more control of what we're trying to do. But what if I want to say, hey, you're old enough to drink, but you're also not old enough to drink? If I can do another if statement. I could say if age is less than 21. Hey, let's print come back when you are older. Let's make this person now to be 12 years old. And you'll see now we can do another if statement, but that's not as efficient. If I wanted to do a bunch of these if statements, what if I want to link them together? That's why I have this if-else statement. I have if statement, like we've seen before, then instead of just going back to normal code, right, without indented, I can run an else statement. Right, so if this condition is true, I'm going to run these 2 lines of code. Otherwise, I'm going to print come back when you're older. So let's go ahead and see how that looks, right? Come back when you're older. Now let's set them up to be 55, and now they're old enough to drink. Now a reminder on indentation that we talked about the first class. Let's go ahead and delete our indentation here. And you'll notice that because it's expecting a code block after a condition statement, we're actually going to get an error because we have to have at least some code in our code block. And so there we go. Expected an indented block after the if statement. But we didn't see one, so we're going to throw you an error. And if you remember, how many spaces are supposed to be after when you're supposed to indent? All right, hopefully you said the answer is 4. If not, no big deal. But that's the standard is 4. So I'm going to put 4 spaces. Now that's a recommendation. It's not a hard and fast rule. I could do I can do 2. 1, 2. As long as they are both lined up, it's going to work just fine. But just so you know, I don't get this little red warning. 4 spaces is what is expected by the integrated development environments, or the IDEs. Okay, so that's an if statement and an else. What if I have some other condition? Like I want to say, what if I want to say if the person's greater than 21, yeah, they're old enough to drink. If they're exactly 21, what if I want to say happy birthday? So let's say we can add This is the if-else, but we can also add this elif statement, E-L-I-F. Now, in most other programming languages, we call it else if, but they shorten it in Python to be cute, I guess. I don't know why they did, but ELIF stands for else if. So I have my first statement, I have a linking statement saying else if, and I can say age is exactly equal, checking the equality sign with the 2 equal sign. Then I can do my print statement. We'll say happy birthday. Okay, so now if I run that, it still says I'm old enough to drink. What if I just turned 21 today? And now I can say, hey, happy birthday. So I have an if. If I have an if statement, that's all I need. I can have an else statement with it, but I can only have one else statement. So if I have an if, it can be paired with an else. And then also, it can be paired with elif. But I can have as many elif statements as I want. So let's say, hey, we'll say if they're 22 or 23, we'll say happy 22nd birthday. Yeah, I didn't want to do that. And this one will say happy 23rd birthday. And here we'll say happy 21st birthday. So you can see now I can have one if, and if I have an if, then I have to pair it with an else. I mean, I don't have to pair it with an else. I can have up to one else, 0 or 1. But I can have as many elifs as I want. I can have 0, 1, 2, 3. I can have 100. It doesn't make a difference. Let's do 22 just for fun. You'll see, hey, I'm old enough to drink, because what happens here is the first linked statement that gets executed starts at the if. If the if statement equates to being true, then it's going to print the code blocks below it, or it's going to run the code block below it, and then break out and go all the way down here to the end. Because these are kind of, all these statements here are all linked together. As soon as one gets executed, only one code block can happen. It can either be the if code block, any one of the elif code blocks, or the else. But you can only run one set of code blocks for an if block of code, or for an if statement. So in this case, as soon as 22 came in here, this equated to true, it printed old enough to drink, and it ignored this statement down here. So let's change this here to be if it's greater than 24. And now our code should work as intended, right? Happy 22nd birthday. It got to this section of code. What if I put down here 22nd also, right? I had a typo and I wanted to get down here. I can never ever run this line of code because this elif statement happens first. It's the exact same condition statement. It either equates to true, in which case the Python will run this statement and ignore everything else, or if this equates to false, this one will also equate to false. So this is what we call dead code. We can never ever get to execute this line of code. You'll notice that we can never get it to say happy 23rd birthday, no matter what we put in there. Okay, so that's if and else statements. So if, else. And then in between those, we can have a bunch of elif statements. So now I'm going to challenge you a little bit. Let's go ahead and cut this out here. The challenge is to write code to test if the variable a is greater than or equal to the value that's stored in variable b. Hey, if it is, I want you to print a. Otherwise, I want you to print out the variable b. So I'm going to give you, go ahead and pause the video and take as much time as you need, but come back here when you think you have the answer. Okay, so I wrote the code here, and I did it as a simple if statement with an else. So the first statement is if, and I say A, let me run this set of code real quick. A is greater than B, in which case 4 is greater than 2, so this should equate to true, and it should print out A, right? All right, so that's the correct answer. This is an if-else block. Remember, if I have an if statement, I'm allowed only one else. I don't have to, but I'm allowed 0 or 1 else's. But I can have as many elif statements as I want. So I could say, as an elif, A minus B, since we know A, if it is true here, then B minus A is going to be always going to be some positive number, right? Because if it fails this statement, we know B is actually bigger than A. So therefore, B minus A has to be a positive number. So I can say if it's equal to 1, print B is 1 bigger than A. I could add another elif. B minus A is double equal to 2. So I'm doing a comparison, and I didn't want to do I want to do minus. And let's put spaces. I don't know. I know I don't need those, but it just kind of makes the flow of the code look cleaner when I have the spaces. There's no difference if I have a space here or not, but I just like to have it so it looks cleaner. All right, we're going to put our colon statement here, and we're going to say print B is 2 bigger than A. All right, in this case, let's change B to be 6. I'm going to rerun this section of code, so I've updated the variables. Now A is 4 and B is 6. Let's go ahead and run this. And before I run it, I want you to run it through in your head. Let's go ahead and do that as a mental exercise here. So the first statement is A greater than or equal to B? And the answer is no. Therefore, we're going to ignore this section of code. We're going to check the first elif statement, and we're going to say, hey, B minus A, which is 6 minus 4, which is 2. We're going to say, is 2 equal to 1? And the answer is no. So I'm going to ignore this line of code. I'm going to go down to this elif statement. I'm going to say, hey, 6 minus 4 is 2. Is 2 equivalent to 2? And the answer is yes. So it should print this statement right here. B is 2 bigger than A. And we got our result. Now if I make B 7, which makes it 3 bigger than A, and I run this same set of code again, you'll notice that it's going to print out the answer of B, because that's the else statement. Now, one thing I want to point out, if you're following along, you must update your variables. I'll put this back to 6. You'll see how it turned orange. Until I run it, it's still going to be orange, right? So anytime I make a change, it'll be orange over here. So as soon as I make that change, it'll turn to blue. So now that means the variables have been updated. So when I come back to this block of code, you'll see that it now prints out B is 2 bigger than A, because otherwise, if I change this now to 9, and I rerun this block of code, it still thinks A is 4 and B is 6. So it's still printing 2 is bigger than A, even though it looks like I've modified it. But how you see how it's orange is it hasn't been updated. So I got to update it first. Then I can run this section of code. So that's one little caveat I wanted to throw out there. I don't want you all having those headaches of trying to figure out why is my code not working when it's because you haven't updated your variable. Okay, so we've kind of talked about the if-else statement. We learned the structure. It goes if, then we have some Boolean expression. And we learned about the Boolean expressions on day 1. If I open up that tab and we go all the way to the bottom, we'll see here's all of the comparison operators. And these all equate to Boolean expressions, right? So we take numbers, we do comparisons on them, and then we give back Boolean results. So if statements, which are control flow statements, look at these comparisons and decide whether or not it's going to run the block of code below it. Then we also end comparison statements with a colon. This tells it that this statement, remember statement's one line of code, now after it is going to have a block of code associated with this condition. And a block of code is everything that's indented to the same level. So in this case, these two statements are both indented, therefore they're part of that same block of code. And if this condition is true, it's going to run both of these lines of code. Otherwise, it's going to go to the next condition and check it for equality and see if it's true or not. Okay, so that is our if functionality, how we have it set up. We have the comparison operators, we've talked about that. One thing we haven't talked about is nested if statements. I can put in a block of code another condition statement. Right, so I can say, hey, if this person is greater, I'll copy this code, I don't want to lose this code. I'm going to copy this code, bring it down here, and we're going to modify it. We're going to make these a nested statement. So I have my if and I have my else. This is kind of what we had set up before. I'm going to change this to 21. So I have, and I'll get rid of this type. I don't need this statement here. So make it real simple. All right, we have the variable age. We define it as 22. We check to see if they're greater than 21. If they are, then we're going to print old enough to drink. Else we're going to come back when they get older. Okay, works just like we expected. But instead of printing old enough to drink, we'll keep that statement in here. Let's add another if statement inside of this if statement. You see how this if statement has no spaces in front of it, so it's part of the main section of code. This if is indented, so it's part of this block of code. So these two lines are part of the same block of code. So let's add another condition in here. Say age double equals 21. Again, my spacing for functionality. And we'll print barely old. Then I could add, well, let's just leave it at that, right? So I have this if statement, and it's tied to this else statement. Now I have this nested if statement that's part of the first if statement's block of code. So this only gets executed if this statement is true. So let's go ahead and run that and see how this works. And I want to set the age to be exactly 21. And oops, I forgot to say 21 equals. See, this is why we got to make sure that we check our code and debug it. There we go. So now it says old enough to drink because they're exactly 21. Then I also printed out just barely old enough, right? If I change them to be 27 and run it, they're just old enough to drink. They're not just barely, they're definitely old enough to drink. Okay, so this is a nested if statement. It's an if statement that's inside of a code block of a previous if statement. And I can do multiple nested if statements. I can say if age equals 21, then I can say if, we'll say birthday, birthday today. And if that's the case, then we're going to go ahead and print. We'll spell it out. I don't want to have a bad variable name. Birthday underscore, and we'll say today. Then we'll print happy birthday. So let's define birthday today as a variable, and I'm doing it as a comparison. So what data type do you think birthday should be? Hopefully you said Boolean, which is a true or false, so we'll say today is their birthday. There we go, I can type today, and we'll go ahead and run that, and you'll say, okay, well, age is exactly 21, and it's not, so or it's greater than 21, so it prints old enough to drink. Then we say, hey, is the age exactly 21? It's not, so it doesn't run this block of code. It kind of just ignores it and goes to and prints our end statement. So what exactly, if they are exactly 21, and today is their birthday? So we'll go ahead and print, hey, we're old enough to drink, and we're printing happy birthday because it is their birthday. So I could do this nested if statement, and that works just fine, but it's not quite as readable as I'd like it to be. So one other trick we can do is add conditional statements with what we called, if we go back to launch number here, we had the conditional comparisons, and then we also had the logical operators. So we learned about and, or, and not. Instead of doing this nested, let's do it with an and statement. And I can say and birthday today. Instead of having this now as a nested statement, I'm going to go ahead and print that out. There we go. So now I have it as a birthday as a nested if statement. Okay, so that's really what I wanted to talk about for dealing with if, nested if statements, else statements. The big takeaway is if I have an if statement, I'm allowed one else statement that's paired with it. And it's got to be at the same level of indentation. So this if statement has an else statement. This one here does not have an associated else statement. So it only condition is if this happens to be true, it prints this out. Otherwise, it continues on down to this print statement down here. All right, let's shrink some of this stuff up so we can get back to our notes. All right, so from our notes, we learned about the if-else statements and how we're going to compare those. We learned about the comparison operators from last class. The assignment operator is 1 equals. The 2 equals sign is our comparison operator. That's what we use in our flow control. So our if-else statements are going to use the equality operator, the 2 equal signs. And then we looked about nested statements where we have one if statement, and if that's true, then it goes into a code block, and in that code block is another if statement. So that's what we call nested if statements. And we can get pretty complicated with nested if statements. Then we learned about elif, which is short for else if, and this allows us to do multiple conditional statements in one section of code. I don't even know what we call this, but like this if statement all the way down to this elf is kind of linked all together, right? As soon as it finds a true condition, it runs that block of code and then exits out of this entire section of code. So if it runs this, if it passes this check here, then it'll come all the way down to this print of the end. If it fails this check, it goes to this one and checks for this one. If it passes this statement as a true statement, it'll print this out, and then its next line of code it'll execute is way down here at the end. So that's how elif statements operate. As soon as one is a true statement, it runs that block of code and then jumps down to the end. All right, now let's move on to talking about switch statements. And I learned them in C programming languages, so that's the term that I'm always familiar with. Python didn't really implement them until it got to Python 3.10. In fact, I think Guaido's reasoning was, hey, you can do switch statements using if and elif statements. So why duplicate effort and do the same thing a different way? Well, the reason I like to use switch statements is they're easier to read, right? They're as a looking at the code, it's more intuitive on how they work. So we call it match case in Python. So you might see the term match case, and in textbooks you might still see them call it switch case just because that's the lineage of where it came from. But know that it did not start until we get to Python 3.10. And it does function very, very similar to the if-elif statements that we saw earlier, right? But because it requires fewer lines of code, it looks a little cleaner to read. In fact, here I got my example right here. Here's where we're going to start using the keyword match. And I just have some, let's call this OS instead of language. We'll say OS here. And I'm going to input, I'm going to ask a question, what operating system is on your computer? And if I run this section of code, oops, I got to fix this. Where is that? Why is it not like? Undetermined string literal at line 7. Oh, I don't need that space, I guess. Oops, Control Z. Let's go ahead and run it again. There we go. Oh, no, still doesn't like, oh, why do I have, Linux didn't get its close with quotes. That's the problem. There we go. I should just read the error message and see what it says. Okay, so I asked the user, what operating system is your computer? And in my case, mine is running Windows, so I'll go ahead and run Windows. And the way it works is it's going to hit this match statement using this variable OS, which is whatever the person typed in, and it's going to go down and do a comparison. Did they type in the word Windows? If they didn't, did they type in the word Linux? Did they type in the word OS X? And it's going to go down until it finds a true statement. The final statement is our famous underscore, and that's a catch-all. That's the equivalent of the else statement in an if-else block. If it gets down to here, it'll run the default case and just print out this line of code. So let's go ahead and run this again. And I'm going to say, this time I'm going to say Linux. I'm going to hit enter. Hey, root all the way, right? So that printed all the way down here because that's my Linux. Now, Python is very much case sensitive, right? So if I run and I say Windows, look at that. OS doesn't matter. What matters is solving problems with Python, because it's doing an exact comparison to what they've typed in. One way I can fix that is to do something called title to lower, I think is. And I'm not sure if it's a capital T or not. And then I make everything lowercase. Android and iOS. And if I run this and I type in so it's not too lower. It must be capital T. Or is it just lower? I don't know what I'm doing, so let's go Google it. Python string to lowercase. Ah, it's just the word lower. Gotta love it. That's what I do a lot during out my day, right? I don't remember the exact syntax on how to do something, so I hit up Google or I hit up ChatGPT, say, how do I do this? So we'll do that again. So no matter what case that I write it in, when I get this line of code, it's going to make it all lowercase. So you can see that it compared and actually worked just fine with Windows here. We'll go ahead and run it again, and let's type in OS X. We'll do it all cap, OS X, and Macs just work better, right? So that's my example of why I use match case sometimes, or in other programming language you would call it switch case. Much cleaner to write, right? If I had to do this in if-else statements, you would have ifs and colons and everything all over the place, elifs, and it's just much cleaner and easier to see what we're doing when we use the match case. All right, my favorite section for this module is talking about loops. Why do I like loops so much? Is because this is where programming really shows its power, right? I can write an application that scans a computer, shows me all the processes that are running, shows me all that, and I write it one time, and then I loop it and process it over my entire network. So even though it takes me a good long while to do one computer, behind the scenes, now I've done it once, I can do it hundreds of times over and over again at the power of the computer. So loops are very influential in that way. The structure is very similar to our if statement. Remember, for our if statement, we had the word if, we had some bool condition statement. So this could be greater than or equals, double equals, it could just be the word true, whatever the statement is, and then we had a colon. And then right after that colon, we had an indented block of code, and we could have 4 or 5 lines of code, as long as it's all indented the same, is all part of that one block of code. That's exactly the way loops work And we're going to start with one called a for loop. So I'll use the for. I'm going to do some condition statement here, and I'm going to do I in some list of items. Let's just do, we'll just say 1, 2, 3, 4, 5. Then I have a colon. Then I'm going to print out the variable name that I gave it here. Right? So this is a variable name. Just like we saw before, I would say something like I equals apple or whatever I'm going to do the assignment. A for loop will take whatever's in the in statement, so we have the word in, whatever's on this side of the in statement, and one by one it'll pass it into the variable I, and then it'll go and do the entire block of code below. So in this case I'm going to just have one line in a block of code, and it's just going to print out the variable I that I have here. So let's go ahead and run that. And you'll see that it just goes through our, what we call a tuple of items here, or just kind of our linkage of items. I don't want to use the word list because it's not really a list. Let's make it a list. So that way I can use the right terminology here. So it's going to go through my list of items, and it's going to go, and the first time through I is going to be 1. The second time I is going to be 2. The third time I is going to be 3. And you'll see that I'm just going through my list over and over again. Now it's a very simple block of code. I'm just printing out a variable. Now this is a list of items, but what if I just had my string here? We'll use apple as our example. Our example, since it starts with a quote and ends with a quote, is a data type of type string. This print statement is going to go through each letter one at a time, printing it out on the screen. So we'll go ahead and run that. And you'll see, and that's how that gets printed out. Now I said the word letter when I said string, and I told you strings aren't just letters. You could have numbers in here. We could have special characters. So the proper term would be character. So each character in my string is going to be how would I write the term? State this term. Each character is iterated. That's what a fancy word for looping through. Iterated over, and the variable I is assigned a character each iteration. So if I run that, you'll see how it writes out, right? So I got A, P, P, L, E, 1, 2, exclamation, @ sign. So that's what happens when I have a string over here. Loops, for loops are great for doing defined number of items, right? Since there's a finite number of letters in here, I'm going to iterate over each letter one time, and that's going to be my loop. There's also another type of loop called a while loop. While loops are great for doing things an indeterminate number of times. So we can really decide at runtime how many times we're going to go through. Now I could, in a while loop, do a defined number of times. I could say while I is not, we'll say double equals @ sign just for fun. I'm going to print I. And I'm going to say, oops, while I, okay, and then, well, let's do our list. I think the list is easier. While I is not equal to, we'll say 5. And I want to say not, so I'm going to add the word not here. I'm going to create a list, and I'm going to say items, and I'm going to come up with my list of items. We're going to say 1, 2, 3, 4, and 5. Then I'm going to create a variable called j, and I'm going to set it equal to 0. What j is going to allow me to do is reassign the value of I as I iterate over items. So the first thing I'm going to do is say I is equal to items of j. And this syntax is going to be a little bit funky, But what I'm saying here is I have this list of items, right? So items is 1, 2, 3, 4, 5. The variable I is going to be the jth item in this list. So this is actually the 0th item. This is the first item, second item, third item, and fourth item. Python starts at 0, so that's a little bit confusing. So let's actually start this at 0. So we'll say 0, 1, 2, 3, and 4. So I'm starting at 0, going through 4. So now it'll make more sense if I print out what I is here. And I'm going to use my example of what I told you before, is where I use comment signs to not run code while I'm testing. So here all I want to do is print out, let's comment this out as well. Right? All I want to do is create my list of items, create the variable j, and then index my items with the index of j and assign that to my variable I and print it out. Wow, that's a mouthful. And you'll see that I get the value of 0. If I change I to be 4, you'll see I get the value of 4. Now you may think that j is just getting put into I, but that's not the case. It's whatever is in the fourth element. So if I put the number 10 here and run this, you'll see that I is equal to the value of 10. Now let's go back to our while loop, and we're going to say while I is not equal to 10. If that's the case, I want to print out 1, 2, 3, 4 spaces. I want to print out I. Then I'm going to increment j, so j equals j plus 1. Then I'm going to say I is equal to items of j. What that's going to do is it's going to go through my entire list and print everything out. Oops, I meant to print. Let's comment this line of code out. I don't want this one anymore. So is I equal to 10? The answer for the first time through is no. I'm going to start this at 0. And so the first time through it is not equal to 10, so I'm going to print out I. Then it runs all the code, comes back up here and says, now I is now equal to 1. Is 1 equal to 10? And the answer is no. So I'm going to print I, increment j, so now j is pointing at 2. And I'm going to assign that to I, and I say, hey, is I, which is now the value of 2, equal to 10? The answer is no. It runs through my print statement and just kind of cycles through all the items in my list until I get to that last item where item is it equal to 10? And it says it is equal to 10, so break out of my loop and don't do any more iterations of my loop. So just like I did in a for loop, I can do the same thing in a while loop. But look how much more things I have to set up. I've got to set up a counting variable called j. I've got to have an assignment variable called I that I'm assigning the value into. That's why I love the for loop. It's so much more elegant, right? I can just say, I can put a block here and I can just say 0, 1, 2, 3, 4. We'll just get rid of the fourth one. And let's comment all this out. Oops, that didn't work. Let's do it line by line, apparently. And we'll go ahead and run that. Okay. So in 2 lines of code, I did the exact same thing I did in 1, 2, 3, 4, 5, 6, 7 lines of code. So that's why I like for loops for doing something a defined number of times. Fewer lines of code, easier to read, much easier to understand. Where the while loop thrives is doing things an unknown number of times. Let's look at an example for that. We're going to say item. And we're going to say is equal to input. So we're going to ask the user a question. Item, do you want to add to your shopping list? Oops. Okay, now I've got the item that they want to put in there, let's put it in shopping cart. Let's create a shopping cart first. Shopping underscore cart is equal to an empty list. So now I'm going to say shopping cart. And again, this syntax, because we haven't gotten to lists yet, might look a little foreign to you. We're going to use append, and we're going to put in that item. So don't worry about the syntax here. This, all it's doing is adding the item that the user put in to this shopping cart list. Then I'm going to say, actually before I do this, I'm going to say if item is equal to exit, then I'm going to break out of my loop. There's a break command, and I think that's part of our topics, right? So I need to talk about loops. Do I talk about break statements? Yes, I do, right here. How to break out of a loop. We're going to use the break statement to be able to break out of our loop. And I'll talk about continue here in a minute as well. So we'll talk about those two concepts. Now I've got to create my loop. Let's say while. I'm just going to use the word true. And then now I got to make sure everything is part of my while loop. So it has to be all part of that block of code. I have to indent it 4 spaces each item. So item is input from the user. If it's the word exit, I'm going to break out. Otherwise, I'm going to append that to my shopping cart. And at the end of the whole thing, I'm going to print my shopping cart. We'll go ahead and run that. What item do I want to add? Apples, toast, fruit, bananas, I don't know. We'll just exit. There we go. So now I print out my shopping cart, and it's got apples, toast, fruit, and some bananas. Now this is not a great application, but at least you start to see some of the utility. I could make a shopping cart app where I'm adding things to an item list, and I can do some comparisons on it. We can do some conditional statements. We've learned some new keywords. We've learned the break statement that breaks out of a block of code. So this statement here goes up the chain and says, where is a while loop or a for loop or any looping condition? And if I see the word break, I'm going to go to the end of this block of code. See, this block of code for the while loop are 1, 2, 3, 4 lines of code. The break statement says, okay, break out of these 4 lines of code and go to the 5th line, this print statement. So it basically exits the loop and runs the next set of code right after the while loop. That's what the break statement does. What if I don't want to allow them to add certain items? Let's say, hey, if item is equal to, I'm out of apples today, so we'll keep with our topic of apples. If they try to type in the word apples, I can't add that to their cart, so I'm going to hit the continue button. So if they try to add it to the cart, I'm going to print not in stock. And then I'm going to hit continue. What continue keyword does, it says where's the while, the for, or any other looping condition, and jump straight back to the beginning of it. So this continue will jump straight back to the top of the while loop, whereas break jumps straight to the end of the while loop. So if they type the word apples, I print not in stock, and then I continue again. So let's see how this line of code works. What do I want to put in there? Let's do bananas. B-A-N-A-N-A-S. We're going to add apples. Wait, those are not in stock. Can't add those. Okay, let's add grapes. Let's add melon. Let's add pears. Let's exit. So you'll notice apples is not in our list because as soon as I hit the continue statement, it never added it or appended it to our shopping cart because we went straight from here back up to the top of the while loop. So I did get my bananas, grapes, melons, and pears, but I did not get my apples. Okay, so we've hit break statements. Oops, I don't mean to click in there. We hit break statements. We've hit continue statements. We understand those. We've looked at for loops and the value of iterating over something a defined number of times. We've looked at while loops, where I can do it while a condition is true, and I can do it an indeterminate number of times, right? The user really defined how big the shopping cart was at runtime. Until they type the word exit, I'm just growing and growing and growing my shopping cart list. So I might do this while loop 100 times. I might do it 3 times. I don't know until I actually run the code. Whereas with with a for loop, I know I'm only going to run it 4 times in this case. Or I might run it 10 times if I have the variable called range. Let's do 10. Right? This is going to run it exactly 10 times. Right? 0 through 9 is 10 iterations. And we start at 0 in Python. I mentioned that earlier. And that's a good reason, right? So if we start at 0, we can index items at 0, but I go to 1 minus the final value. So I go to 9, not 10, because I want to have exactly 10 items. So 0 through 9 gives me 10 items. Okay, so looping, we did loops iterating over a sequence, such as a list, a string, or a range. I've shown all 3 of those, right? We did it with the word apple, where I printed out apples. And actually, let's go back and get our emojis. See if I can copy and paste an emoji here. Give me that one. No, I just want to copy and paste one. Got that one. Let's see if I can paste that in here. Do a couple of thumbs up. Okay, there we go. I print out the word apple, and then I print out a bunch of thumbs up. So that's iterating over a string. Iterating over a list. We said list start with square brackets, and we'll learn that on day 3, but we can just see that's a comma-separated set of items. And I can just iterate over 1 at a time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I just put them in number order. I could make this 7, 2, 3, and 5. I don't know, something like that. And I can print that out as well. So whatever order the items are in this list is the order they're going to iterate over when I print them out. So that's printing over a list. We've seen printing over a string, and we've also seen printing over the command called range. Range is a fun thing. I can do something like, I don't know, let's do something 100 times. All the value that I put in there is going to be in there, so it's going to go from 0 all the way up to 99. So the way it works is it's actually starting an implied 0 and going to 100 this way. And it's implied that it's also doing it in steps of 1. So the real way to use range is to give it 3 values. The start index, the end index, and then how many items we're going to skip in between. So I'm going to go from 0 to 100, and including every single item. So we'll go ahead and run that, and you'll see that's exactly the same. What if I want to do every other item? I could do 2. And you'll see that that gives us the even numbers. If I did 3, it would give us multiples of 3. So 0, 3, 6, 9, 12. What if I, one thing I want to point out, it includes the first number. Well, let's do it a 10 real quick, and we'll do it in steps of 1. If I see it includes the first number, but it does not include the last number. So the way you know the number of items that are going to be in your range is you take this number minus this number. So in this case, it's 10 minus 0, so there are 10 items, and they start at 0, so we get 0 through 9. What if I started at 1? Well, let's do the math. 10 minus 1 is 9. There we go. I have 1 through 9, and that's 9 items. If I did, I don't know, we'll say 8. 10 minus 8 is 2. You'll see I have 2 items. It starts with the first number, ends with 1 minus the last number, and it goes in increments of the third number. Now, if I don't include the third number, it's an implied 1. So this will give us the exact same result. If I did it with a 2, it'll give us every second item, so it'll only give us 1 item, right? Starts at 8, goes to 10 in steps of 2, but it doesn't include 10, so it can't include anything past 8. If I start back at 0 again, you'll see that it's going to give me the even numbers, up to but not including the 10 minus the 2. Okay, so if I don't have this number, we said it's an implied 1. And so you'll see it does all the items. If I don't have this first number, it's an implied 0. So you'll see that if I only give it one number, it says, hey, let's do everything up to 1 minus this last number. So it goes up to 9. So ranges is a really cool function. It gives us an easy way to create a defined number of items pretty quickly. It also gives us some flexibility where if I want to do only even numbers, I can do even. If I want to do multiples of 4, I can do multiples of 4. Where am I? Oops. I forgot to do, I got to start at 0. I can't just add a step size. I have to start with, if you have the step size, you have to have the starting number. There we go. So 0, 4, 8. All right, so that's range, and it's used a lot in using for loops, just to do something a defined number of times. All right, we've seen loops. We haven't seen an infinite loop yet, something that just keeps going on and on and on forever. That's where it always evaluates the true. So actually, we have seen an infinite loop, and that's what this while statement is. It's just while infinitely true. Instead of doing this, I could say while item is not equal to apple, or exit, I'm sorry. And I have to define item up here as item is equal to an empty string. And so that way the first time through into my loop, it is not equal to the word exit. Let's go ahead and break out of this section of code so we don't need the break statement anymore. We're going to break based on the exit criteria here. So we'll go ahead and run and see what happens. What's the difference? So before I had a if condition statement and looked for the word exit. Now I've put the condition here in our while loop. So is there a difference? And if so, what do you think the difference is? Let's try to add grapes, I don't know, pears, melons, exit. The big difference is, because I didn't have that break statement before adding to my shopping cart, I actually added to the shopping cart the word exit. So that's why I had that condition with the break statement in there, is because I didn't want to append the word exit into my block of code. So let's see, is there a way besides break that I could have fixed this section of code so it doesn't append the word exit? Go ahead and see if you can modify this code by adding something to this if statement to see if you can not append the word exit to our block of code, yet still run efficiently. So go ahead and pause it and see if you can modify that. All right, hopefully you were on the right track and you said, let's use conditional operators, the if statement, with logical operators, the and statement, or I'm sorry, the or statement. Or item is equal to assignment, not the assignment, the equality operator is equal to exit. So what this if statement now does, if it's apples, hey, it's not in stock, let's go back up and exit. If it's exit, it's going to say not in stock, which is not what I really want, but it's going to continue, and then it's going to hit this line and say, okay, let's not add it to the shopping cart, and let's go straight to just printing the shopping cart out. So we'll go ahead and run this. Grapes, bananas, melons, apples, pears, exit. All right, so we kind of fixed it. It doesn't have the word exit in here, but it still has not in stock when I said the word exit. So not exactly what I want to do. The only real way to fix that is to do, I could do a nested statement. I could do something like if item not equal to exit, then I'm going to have this block of code print. So now we've kind of fixed the code, but it's a little bit ugly because I have an if statement with a nested if statement when I don't really need it. So there's other ways to kind of clean that code up as well, but for now I want to just kind of see how the logic flows, and we want to make sure the code functions correctly. Pears, grapes, bananas, apples not in stock. Let's add melons, and let's exit. Great, I didn't get the not in stock when I typed the word exit, and I got the shopping cart list right there without the word exit in the shopping cart list. So that's a lot to take in. Want you to try to run and do these examples. I want you to type them out yourself, please. That's the better way to do it. You can download and use my Day 2 IPython notebook, but I'd like you to retype everything because that hands on the keyboard really solidifies learning how to do these commands and what's going on as the interpreter is reading each statement of code. And remember, again, statements are a full line of code, right? From each line of code, we're going to say is a statement that gets executed. All right, let's go back to our handy-dandy list of things I want to cover. So we learned about loops. We looked at for loops, and we looked at loops with while statements. We looked at the range function. One thing I haven't looked at yet is nested loops. So loops that have loops inside of them. So where might this be handy? Especially two-dimensional. Can you think of anything that's like a two-dimensional type structure? What about an Excel spreadsheet where I have rows and columns? What if I had some for loop that says for call in columns? Let's do, our columns are going to be name, comma, address, comma, phone number. And that's going to be my first loop. I'm going to iterate over every column. Then I'm going to iterate over every row. So we're going to do for row in, and I'm going to come up with just a set of numbers. Let's do square brackets, and let's do 1, comma 2, comma 3, comma 4, comma 5, comma 6. I'm going to indent there, and let's print out. Actually, let's use our fake data. Remember how we did fake data earlier? Let's pull up faker and try to put some fake data into our pseudo spreadsheet here. I just got to remember the syntax for faker real quick. I should probably just Google it. Faker data. Do they just have a quick and easy example here? Yep, here we go. We're going to copy this. We're going to come over here, and I'm going to import from Faker. I'm going to import Faker. I'm going to create an instance of it. Now what I'm going to do is I'm going to say if call is equivalent to name, what I want to do is I'm going to print out let's go ahead and just run this to see if that works. What am I doing wrong here? Okay, no module faker found. Did I not save that when I did that last time? I may not have installed it with this particular integrated development environment. Nope, I didn't. Yes, I'm on a different one. So we need to pip install for faker. But I got to change to the 311. So I got my faker. Oops, where'd that go? There we go. Where'd it go? Come on. I think it's still scanning. That's what's going on here. You know what? I'm just going to run it through the terminal. Let's figure out what version I'm running here. Alright, so I am running the correct module after I changed to the right one here, so now I can do pip install and my keyboard's acting up again. Alright, so we're going to install faker, and what that's going to do is going to go to the internet, pull down this fake data generator for us, and go ahead and install it so I can use it inside of Python. And this will probably take a good minute or so, so we'll give that a minute to install. Flaker, that's why it's not showing up, faker. Oh, here it goes. Okay, we're going to go back to our Jupyter notebook here, Jupyter Lab, and it still hasn't fully finished yet, so we'll give it another minute. I was hoping it was going to install, but not letting us know when it's finished. All right, while we're doing, we're going to kind of finish with the code, what we think the code is going to look like. So if call is equal to name, we're going to put a name. If call is equal to address, and I'm going to change this here in a second to be capital address. Remember, Python is case sensitive, so I want to have address and phone all be capital. Print fake.address. And then last is if call is equal to phone, print fake.phone. And I'm not sure if it's phone or phone number, but we'll see here in a second. All right, let's see if we finished installing everything. Looks like we did. So let's go ahead and see if we can run this code. It does not look like, yeah, it did not find module faker. All right, we're going to take this over to, copy this, and bring it over to PyCharm, and we'll run it right in here instead of running it through. Oh, did I copy the wrong thing? I did. Control C, Alt Tab over. There we go. So now you'll see that it looks a little different highlighting, but the keywords are orange here versus dark green in the other one, but we can see the same kind of code and see what happens here. And I do get an error on phone, right? So it's not phone. Apparently phone is not correct. The nice thing about IntelliSense, does it have number maybe? Nope. What else does fake have? If I hit the dot, it shows me all the different values that I can put in here. So, does not seem to have. Let's jump on the internet. Say faker. Is there a phone in here? Okay, how do we do phone number? We can use country calling code. What else do I just phone number? Yep, phone underscore number. There we go. Gotta love the internet. Get rid of the second dot and go ahead and run this now. There we go. So it starts with, actually let's do it, gives me the 5 names, it gives me the 6 names. Then it goes and gives me the 6 addresses, then the 6 phone numbers. Let's structure it so it's going to give us in the inverse order. So I want to go this first on the outside, and I'm going to indent the columns here. So what I did here is I switched it to go row by row, and in each row it's going to give me the name, address, and phone. We'll go ahead and run this. Now I have it in a little bit better order. This is Marcus Hall, the address, and then the phone number. Let's add one little thing to this to make it a little cleaner. And let's add end equals nothing. So I don't want it to, maybe I'll do a space. That's what we'll do, a space. Because default, if I don't set this, which again, this is way advanced, so don't worry too much about this. What it's doing here is it's, instead of giving it a new line, it's going to print everything on the same line with just a space in between. So now we have Jason White, the address, and it's 2 lines for the address, and then the phone number. But then Sharon McDonald gets put on the same line. So we do need an end line at the end. So let's go ahead and do that one time here. We're going to say print and just give me a new line. One more time through. All right, so now we've got it kind of what I wanted. I have Donald Erickson, the address, then the phone number. Then I have Jennifer Scott, address, and lastly the phone number. So that is a nested loop, right? So I'm iterating over, going through 6 rows, and I could do 10 rows, I could do 4 rows, whatever I want to do in terms of rows. This is the how many rows I'm going to do. Then on my inner loop, I'm doing name, address, and phone. So it's going through one of those at a time. Then I'm saying, hey, if it's the name column that I'm on, go ahead and print a fake name. If it's the address column, go ahead and print a fake address. If it's the phone column, go ahead and print a fake phone number. And then, once this whole loop is done, print on line 11, just give me a new line so it's a separation between the different people. In fact, let's print this out twice, just so we get a better separation. Actually, we can do 3. So now when we look at the results, you'll see kind of more separated out, right? So Jacob Garcia's information, Melissa Reyes's information, Luke Bell, and you see how we separate them out. So that's my process for showing and going through writing software, right? I start with stuff, I test it out here. Now I would make this and move this section into my actual production code as I cleaned it up. But I'm going to write small little things and test stuff out before I move it into my bigger block of code. Go back here. Let's make sure that we hit everything on our to-do list. We looked at nested loops just now. We've hit the range function. We learned the structure for loops, just like the structure that we had for if statements. You got the keyword, Then you have, in the for loop, we have a variable name that we decide. We use the special keyword in, and then we give it some item that's iteratable. Could be a range, could be a string, could be a list. And we'll learn next class, or next day's class, so class number 3, we'll learn how to make these data structures such as lists, tuples, and dictionaries. Okay, moving up here, we saw the switch case, which in Python we call it match case, and how we saw how it made it look much cleaner when we want to do a bunch of different conditions. Right, so we have the keyword match, then we give it some variable here. In this case, I gave it a string from whatever the person typed in, and then I'm going case by case for the different options that they could have chosen. Right, and then as soon as it finds one that matches the criteria, it'll run this block of code and then exit out of our entire match block. So the match block is this huge thing, but the conditions only have certain blocks of code that they'll run inside of it. So that is our switch case. And then we started with our if and else statements. This is kind of the meat of everything, right, for doing conditional statements. We saw how we could do nested statements, statements with if, elif blocks, and also have an else statement. So if we have an if statement, there we go, that's a tongue twister. If we have if, we can have one and only one else. We don't have to, but we can only ever have one else tied to an if statement. Elifs, we can have as many as we want. Now I can have, if I start another if block, if, I don't know, we'll just say a is equal to 1, print a, I don't know. And I'll say a is equal to 1 for fun. If I run this now, I can have multiple if statements. This is going to create a new if block, which means I can have one more else, because it's going to be tied to this if statement. This else statement is tied to this one. So I can only have one for this if statement. For this if statement, I can have its own else. Print b. And we'll say a is equal to 2. So now when I run this, what did I do wrong here? Oh, I didn't close out my quotes on my string. And there it printed out b. This if statement is tied to this else statement. Okay, so that's really what I want to cover for the condition flow statements and looping. So take a break, we'll get back together and we'll go on and cover the next topic, which is going to be understanding condition statements and how we use that to make decisions in the way Python does its flow of control.